welcome to True Projects. In this video, we are going to explain about the project title, which is Sentiment Analysis and Emotion Detection on Cryptocurrency Related Tweets using Ensemble LSTM GRU model. The project addresses the growing importance of understanding the public sentiment and emotions surrounding cryptocurrencies. In the modern era of digital currencies, social media has a significant impact on market patterns. This project tries to present a solution by creating a complex ensemble model that combines LSTM and GRU neural networks. The program can anticipate sentiment and emotions by studying cryptocurrency-related tweets. This initiative benefits investors, traders, and enthusiasts by providing them with the real-time insights on market sentiment, allowing them to make more informed decisions. The goal of the project is to use deep learning algorithms, which are LSTM and GRU, to execute sentiment analysis and emotion recognition. These algorithms let us to process and analyze a vast amount of cryptocurrency-related tweets in real time, offering significant insights on market sentiment and emotional patterns. The project seeks to achieve high accuracy by merging LSTM and GRU in an ensemble model, making the tool extremely beneficial for traders, investors, and cryptocurrency fans. This initiative provides users with the real-time information, allowing them to make educated decisions in the volatile cryptocurrency market. Coming to requirements, we need hardware requirements in that operating system of Windows, processor of i5 and above, RAM of 8 GB and above, hard disk of 25 GB and above. Coming to software, we need Anaconda 3 and Visual Studio Community version. In the flow of work, we have designed few modules to execute the project. The first one is importing the packages. In this module, we imported various essential libraries including NumPy for mathematical calculations, Pandas to facilitate data manipulation, Seaborn and Matplotlib for visualization, Scikit-learn to facilitate machine learning, TensorFlow for deep learning, and NLTK for natural language processing. Second module is exploring the dataset. In this step, dataset is analyzed to understand its structure, contents, and characteristics, which is crucial for data processing and model building. Next one is data processing. This module focuses on cleaning, transforming, and preparing the dataset for analysis, ensuring it's in the appropriate format for further processing. Next module is visualization using Seaborn and Matplotlib. In this step, Seaborn and Matplotlib are used to create informative visualizations, aiding the data exploration and comprehension. Next one is data cleaning. In this step, data quality issues are addressed, such as missing values and outliers in this module, to enhance the dataset's reliability. Next one is tokenization based on BERT for TL and Keras for deep learning. This step involves tokenizing, which is fundamental step in the NLP, performed using BERT for transfer learning and Keras for deep learning, preparing the text data for model input. Next module is splitting the dataset into train and test. This module involves in dividing the dataset into training and testing sets to evaluate the model's performance on the unseen data. Next module is building the model. In this module, we will build the models using various machine learning algorithms and deep learning algorithms, and they are: the first one is bidirectional LSTM. LSTM is a type of recurrent neural network, which is RNN, that is particularly effective in handling sequential data. Bidirectional LSTM, which is long short-term memory, extends the LSTM by processing sequences both forwards and backwards, enhancing its ability to capture context and dependencies in the data. Bidirectional LSTM is employed in this project because it excels at capturing sequential patterns in the text data, making it well suited for sentiment analysis and emotion detection tasks. Its bidirectional nature ensures it is considered both past and future context when making predictions. Next algorithm is bidirectional RNN, which is recurrent neural network. RNN is a class of neural networks designed to process sequential data by maintaining a hidden state that captures previous inputs information. Bidirectional RNN, like bidirectional LSTM, process the data in both directions. This is used in this project to compare its performance with the other models. It is employed for its sequential data processing capabilities, although it may be less effective at handling long-range dependencies compared to LSTM and GRU. The next algorithm is bidirectional GRU. Bidirectional GRU, which is gated recurrent unit, is another variant of recurrent neural network similar to LSTM but with a simpler architecture. Bidirectional GRU processes data in both directions like bidirectional LSTM. It is used for comparison purpose. It offers a balance between complexity and performance in sequential data tasks, making it an alternative choice for sentiment analysis and emotion detection. The fourth algorithm is GRU, which is Gated Recurrent Unit. GRU is a type of RNN that simplifies the LSTM architecture while maintaining its ability to capture sequential dependencies. It has fewer gates and it is computationally more efficient than LSTM. GRU is employed to assess its performance compared to other models. It is used because of its efficiency and effectiveness in sequential tasks. Next algorithm is LSTM, which is long short-term memory. As mentioned earlier, it is a type of RNN designed to capture long-term dependencies in sequential data. It utilizes memory cells and gates to control information flow. LSTM is chosen as a primary model in this project due to its strong performance in processing and understanding sequential text data. Its ability to maintain context and handle long-range dependencies is valuable for sentiment analysis and emotion detection. Next algorithm is CNN, which is Convolutional Neural Network. CNN is a type of neural network primarily used for image processing, but it can also be applied to text data using techniques like 1D convolutionals. It involves applying filters to identify patterns in the data. CNN is used in this project to explore its potential in text analysis. It can capture local patterns and features in text, which can be useful for sentiment analysis and emotion detection. Coming to the last algorithm, which is Ensemble model LSTM with GRU CNN. Ensemble models combine multiple individual models, which are LSTM, GRU, and CNN in this case, to improve predictive performance. They make predictions by aggregating the results of constituent models. Coming to the next module, which is training the model. Here, in this step, the models are trained on the prepared data to learn and make predictions. The LSTM-based model is identified as providing the best accuracy, and this will be used for the prediction purpose. Next one is Flask framework with SQLite for sign up and sign in. In this step, a web interface using Flask is implemented and utilizing SQLite for user data storage and enabling user sign up and sign in functionalities. Next one is user input and pre-processing. In this module, user inputs the text, which is translated and pre-processed to prepare it for sentiment analysis and emotion detection. Next one is the given input is translated and pre-processed for prediction. Next one is final outcome is displayed through the front end. The prediction results will be displayed to the users through the front end in this module, offering insights into the sentiment and emotions associated with the input text. Coming to the execution, we need to open the code folder which contains the source codes. This is the code folder of the project. This is the static folder. This folder consists of the files related to CSS, JavaScript, and Bootstrap files. And this is the template folder. This folder contains all the HTML pages used in this project. It typically includes the files like index.html, about.html, etc., which represent different pages of the website. This is the app.py file. This file contains the information related to front-end logic. It could include the code written in the Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And these are the model files which contain the algorithm information, and these will be loaded into the project code during the runtime. And this is the notebook.ipynb file. This is the Jupyter Notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute in individual cells. It is a popular choice for the data science. And this is the signup.db file. This file is the database file used to store user information. Now we will open the code folder which contains the source code files, and now we will copy the path of the code folder from the address bar of the file explorer. Now we will open the Anaconda prompt. Using the cd command followed by the space, we will paste the copied path. And this command is used to change the current directory to the code folder's path. Now we will click on enter. So here the current directory is changed to the code folder's path. Now we will type the python space app.py command. This will compile app.py file using the command python app.py in the Anaconda prompt. This command will execute the Python script and perform runtime check for any syntax errors or logical issues. Now we will hit enter. After running the app.py, the Flask framework will host the application locally at the default address, which is 127.0.0.1, which is localhost. Here this is the localhost and this is the port number, unless configured differently. Now we will copy this local link provided by the framework, paste it in any browser. I will paste it in the Google Chrome. Here I will paste it and click on enter. So here this is displayed in the browser and this is the front end built using the Flask framework. LSTM is used to build the model and save it for the user prediction. This is the home page. Now we need to click on sign up. Here I need to fill all these details if I am registering newly. I have already registered, so I will directly sign in. Here I need to give my credentials, which is username and password, and click on register. It has redirected to the home page. In this text box we need to give any text. For that it will predict the sentiment, which is sad, happy, feared or surprised. I gave the message here. Now I will click on the button predict. So here for this particular tweet, it has predicted that the sentiment of the tweet is sadness. Now we will try with the other tweet. I gave the other tweet and I'll click on predict. So for this tweet, it is predicted that the sentiment of the tweet is anger. We will give the other tweet. So I have given this tweet. So for this tweet, it is predicted that the sentiment of the tweet is love. We will try with the other tweet. I gave the message here. So here the sentiment of the tweet is surprise. Now I will try the other tweet. We will see what will it predict for this tweet. So it has predicted that the sentiment of the tweet is fear. I will give the other tweet. So I have given this tweet. So for this tweet, it has predicted that the sentiment of the tweet is happy. In this way, we can give any tweets, any messages. For that tweet, it will predict the sentiment. So we will log out. The project has successfully addressed the requirement for the real-time cryptocurrency sentiment analysis. Project obtained an excellent accuracy in detecting sentiment and emotions from the cryptocurrency tweets by combining LSTM and GRU deep learning algorithms in an ensembling model. This provides significant value to investors, traders, and cryptocurrency aficionados by providing timely information for well-informed decision-making. The ability of the algorithms to evaluate social media data is critical in analyzing market trends in the ever-changing cryptocurrency world. This initiative demonstrates the power of AI and machine learning in improving our understanding of complex financial ecosystems.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.